Hi everyone, good day. Meron na naman tayong bagong presentation or video on vector analysis. So today, we'll be discussing space coordinate systems. So in this particular video, uh, ang focus natin will be on the Cartesian coordinate system. Okay, so let's start. So meron tayong mga common na coordinate systems na ginagamit. So when we say coordinate, systems of coordinate, o it is a system of reference axes used to uniquely describe various quantities. So sa pag-aaral natin ng electromagnetics, we are using these three common uh, systems of coordinates. So meron tayong una yung Cartesian. So yung axis na reference natin dito is x, y, and z. So ito yung pinaka-common sa atin. Then meron din naman tayong ginagamit or gagamitin na cylindrical coordinate systems. So yan yung itsura niya, no? Parang paikot siya. Then meron tayong height and radius and yung angle natin. And then lastly, yung ating spherical coordinate system. So yan yung itsura niya. So bakit nga ba tayo interesado gumamit ng iba't ibang klase ng systems of coordinates, right? Pwede namang lahat ay Cartesian lang, no? Well, it depends doon sa application kung saan uh, ina-analyze natin yung mga vectors. For example, gumagamit tayo ng globe to visualize yung longitude and latitude para ma-determine natin yung distances between 2 points sa globe. So, spherical yung ginagamit natin. So, same yun ang principle na ginagamit sa mga GPS. So, spherical coordinate systems yung ginagamit nilang system of coordinates. Pero, pag mga common terrain sa mga cities, gumagamit tayo ng map. So, Cartesian plane ang ginagamit natin pagka ganun. So, 2D map na yung ginagamit natin. It all boils down into one word kung bakit tayo gumagamit ng system of coordinates. So, dito sa pag-aaral natin ng vector analysis, gagamit tayo ng tatlong systems of coordinates dahil sa convenience. Okay? Hindi ibig sabihin na meron tayong tatlong klase ng systems of coordinates, gagamitin na natin yun sa lahat ng questions or sa lahat ng problems. May mga pagkakataon na mas advantageous gamitin ng cylindrical over the Cartesian. May mga problems naman in which mas madali siyang masolve using spherical over the Cartesian. So, dito sa systems of coordinates, pag-aaralan natin kung paano tayo makakamaneuver from the Cartesian going to cylindrical, Cartesian going to spherical, cylindrical going to Cartesian, spherical going to Cartesian. So, magkakaroon tayo ng mga transformations. Ika nga, para mas madali nating masolve yung mga specific vector analysis problems in this course. Okay? So, palaging yan ang rule natin kung bakit tayo gumagamit ng iba't ibang klase ng coordinate systems. Kung saan convenient at madaling ma-approach ang isang problem, doon tayo. Okay? So let's start by describing ano ba yung Cartesian coordinate system. In the right-handed Cartesian system or the right-handed rectangular system, meron tayong vector A connecting two general points, point 1 and point 2. Right? So, meron tayong 2 points. Pwede nating i-generalize yung vector A na yon as a function of x, y, and z it is equal to the summation ng mga components niya sa reference axis natin. Mga unit vectors in the reference axis. So, sa Cartesian plane, ang ating reference axis are x, y, and z. So, of course, yung component or yung vector component na nandun sa x-axis, ang notation natin doon would be a of x as a function of x, y, and z. Yung mga nasa y naman, ganun din. A sub y as a function of x, y, and z then. Ganun din sa z. A sub z as a function of x, y, and z. Pwede kasing nasa x axis siya pero may mga z variables tayo dito. Pwedeng ganon. Ganon din sa ibang variables. So, introduce na rin natin itong mga formulas na ito. Kasi gagamitin natin yan later on sa pag-aaral natin ng mga differentials, okay, and integrals ng vectors. Okay? So, tandaan lang natin kung saan nakaturo yung ating vectors, we always use the right-hand rule, ha? Okay. So, first, meron tayo ditong differential of length. So, we say that the differential of length, vector quantity yan, it is equal to x hat times dx, the differential of length in the x direction, plus y hat dy plus z hat dz. Ganon din naman sa differential surfaces. Ibig sabihin lang nito, vector area naman to, surface area ng ating field, right? Vector field, scalar field. So, the differential surface in the direction of x is equal to x hat dy dz. So, x, y, z rin yan. May naman siyang x, y, and z. The differential surface in the direction of y is equal to y hat dx and dz, and the differential surface in the direction of z is equal to z hat dx dy. And then meron din naman tayong differential volume. Ito yung product ng differential ng length in x, y, and z. So, dx, dy, dz. So, later on, gagamitin natin yan. So, ini-introduce lang natin. Okay? Next. Let us illustrate yung parang reviewin lang natin itong Cartesian plane, okay, or Cartesian coordinates. So, paano yan? We have here a problem. 3 points are given in the Cartesian coordinate systems. Point 1, 2, negative 3, 3, then point 2, 1, 1, 5, and point 3, 3, negative 1, and 4. So we are to find 3 vectors, vector A connecting point 1 and point 2, vector B connecting point 1 and point 3, and vector C connecting point 2 and point 3. Medyo nabivisualize nyo na yan, di ba? So we have 3 points. So pag mag-connect-connecta kayo ng mga lines dyan, makaka-create kayo ng vectors. So next, we are to find the scalar component of vector A in the direction of vector B. Medyo familiar to kasi doon sa topic natin ng scalar product, meron tayo na-encounter na ganitong problem, di ba? So next, we are also to find the vector components of vector B in the direction of vector C. So ito naman, ganun din sa scalar product or maybe sa cross product, nakapag-solve na rin tayo ng ganito. So let's try to solve yung first question. Find 3 vectors, vector A connecting these points. So again, to mathematically represent a particular vector, i-project lang natin dyan yung ating general formula ng isang vector sa Cartesian plane. Okay? So, x, y, and z. So, in space na to, 3D siya. So, yan yung ating general equation. So, now, sa A, connecting vector, connecting point 1 and point to point 2, we have x hat times, or x hat, 1 minus 2, dahil yan ay point 2 to point 1. So, 1 minus 2. Sa y hat naman, we have 1 minus negative 3. And then sa z naman, that's 5 minus 3. Therefore, yung vector A natin is equal to negative x hat 1 plus y hat 4 plus z hat 2. Yan. So, vector B naman tayo. We have x hat 3. 3, yun yung ating point 3, minus 2. Negative 1 minus negative 3, and then 4 minus 3. So, ang ating vector B would be x1 plus y hat 2 plus z hat 1. Next, sa third naman, we have point 2 to point 3. So, therefore, yung ating first, sa x, we have 3 minus 1. X hat 3 minus 1 plus y hat negative 1 minus 1 plus z hat 4 minus 5. So, yung ating C, vector C is equal to x hat 2 minus y hat 2 minus z 1. So, we already have these three vectors that represents yung mga vectors connecting 3 points. Okay. So, gagamitin natin yan dun sa problem sa B and C. Okay? Sa letter B, we are to find the scalar component of vector A in the direction of vector B. Balikan lang natin yung video na nag-solve tayo ng mga scalar component in the other direction of another vector. So, ito yun. Yan. So, doon sa ating projection ng vector A to vector B, nag-solve tayo ng ganyan. Right? So, ang formula na ginamit natin is that that product is equivalent to the product of the magnitudes ng dalawang vectors times the cosine of the smaller angle between them. So, gagamitin din natin yan dito. Okay? Balik lang tayo. So, the scalar component of vector A in the direction of vector B can be written in this form. A dot B hat. So, it is also equal to the magnitude of A times the cosine of the smaller angle between the two vectors. Yan yung pinakita natin kanina. And it is also equal to A dot B all over the magnitude of V. So, in this case, mas madali kasi itong magamit dahil meron na tayong values ng vector A and vector B. So, yan ang gagamitin nating formula to solve for the scalar component of vector A in the direction of vector B. Okay? So, substitute na natin yung mga values. That would be the scalar product ng A and B would be negative 1 times 1 plus 4 times 2 plus 2 times 1. All over the square root of yung B, di ba? 1 squared plus 2 squared plus 1 squared. And that is equal to 9 over the square root of 6. Yan yung scalar component ng vector A in the direction of vector B. Okay? So, dahil scalar component siya, wala siyang direction. Next, in this sub-problem, we are to find the vector components of vector B in the direction of vector C. So, vector components naman ito. Kaya ang sagot natin dito, merong mga x hat, y hat, or z hat dahil vector components yung hinahanap. So, paano natin gagawin yan? Remember ulit, dun sa dot product, nag-solve na rin tayo ng ganitong parehas na problem na pagkuha ng vector component ng A in the direction of B. So we used the dot product, the magnitudes, and the smaller angle to derive yung formula natin ng vector component. So ang nakuha natin formula is that it is the B times the dot product of the two vectors all over the square root of the magnitude ng vector B. So yun yung gagamitin natin. Okay? And the vector components of vector B in the direction of vector C is given by C hat B sub C is equal to C times B dot C all over C squared. Substitute natin yung mga values. So sa C, we have x hat 2 minus y hat 2 minus z hat 1. Times natin yan sa magiging resulta ng dot product ng x hat 1 plus y hat 2 plus y or plus z hat 1 dot x hat 2 minus y hat 2 minus z hat 1. It is divided all over to the square root of 2 squared plus negative 2 squared plus negative 1 squared. Then, yung square root na yun, i-squared pa natin ulit. So, simplify na natin, isolve natin yung dot product and yung denominator. So, we now have x hat 2 minus y hat 2 minus z hat 1 times, so ang dot product natin is 2. So, minus 4 plus or minus 1 all over 9. So, ang sagot na natin is negative x hat 2/3 plus y hat 2/3 plus z hat 1/3. Yan yung vector component ng B in the direction of vector C. So, ang tinatanong dito, vector components. Okay, vector components. The vector components of vector B in the direction of C are the following. Negative x hat 2, y hat 2/3, and z hat 1/3. Meron kang tatlong vector components ng vector B that is in the direction of vector C. That's it. Mabilis lang itong Cartesian coordinate system kasi palagi naman natin yan ginagamit. Very common itong Cartesian coordinate system. What we have discussed is yung essence ng paggamit ng different space coordinate systems. And then we described yung general formula ng vector given the points, 3 points in a space coordinate, x, y, and z. Then we tried or we solved a problem related to the Cartesian coordinate system. Okay, the projection of vectors into another vector in the Cartesian coordinate system. Okay? So, I hope meron kayong natutunan dito sa video na to. And kung meron kayong question, i-PM nyo lang ako or type nyo lang dyan sa mga comment